This is Mr. Ashton going through the mathematics numeracy paper, higher tier, Unit 1 non-calculator from the summer of 2017. Okay, so the first page is our formula list, as always. I'm going to skip the first 7 questions. They're in the intermediate paper, the last 7 questions from there. So hit the link below if you want to go and see those first 7 questions. And I'm going to go straight on to the first higher tier question, which was question 8. Okay, it says, on a new housing estate, teams of painters paint the walls and ceilings of houses once they are built. It takes a team of 5 painters 10 hours to paint a house that has a total wall and ceiling area of 500 metres squared. A new house on the estate has a total wall and a ceiling area of 600 metres squared. This house has to be painted in 8 hours. Calculate the least number of painters needed in order to do this. You must show all your working. Now, these questions, when they first came out into the new spec, I absolutely hated them. I couldn't get my head around them at all. I find this really, really useful way that I like to answer them, okay? So what I'm going to do is pick out that I have 5 painters. So I'm going to write down a table here that says painters, 5. We've then got time, which would be hours, okay? Hours, 10. That's the worst way I've ever spelled hours. Let's write that neater. Hours, 10. And then we've got an area of 500 metres squared. Okay, so area 500 metres squared. Okay, now what I'm going to do is pick out what I've been given in the information below, which is 600 metres squared. So that's going to go here. I'm also told the number of hours. Do my method is you look at where you know both of them. So like, for instance, I know both the hours, I know both the areas. You're going to write times by 8 over 10 as a normal fraction, the smaller number over the bigger number, and then you're going to write it as a top heavy fraction times by 10 over 8. You're going to do the same thing here. You're going to write 500 over 600 as a small fraction, then underneath is a bigger fraction. Okay, it's a top heavy fraction. So because I'm looking for the painters, I'm going to put 5 there, and that's going to tell me what my number of painters needs to be. I need to work out the journey from this, okay? So we just need to use a bit of logic here. It says 5 painters did 10 hours. Now, I am now going to do here from having 10 hours to do something to then getting it done in 8. So if I had a normal job that I could do in 10 hours and someone said you need to get that same job done, but this time in 8 hours, would it be more or hard work? Would it be more work? So I'm going to go for the more fraction, the bigger fraction. So I'm going to times it by 10 over 8. And then I've got an area of 500 that's gone 600. Is that more or less effort to paint an area that's bigger? Well, that's more effort. So I'm going to choose the bigger fraction again. That will tell me what x is. So x is going to be 5 times by 5 times by 10 over 8 times by 600 over 500. Okay. Now, in terms of doing this was a non-calculator paper, so I'm going to have to make sure that I've made these simpler. So I'm going to divide top and bottom by 100 to get 6 over 5. 5 times, we've got 10 over 8 as well, which we can change into half them, so we'd have 5 over 4. So then we've got 5 times 5 times 6. So 5 times 5 is 25, times by 6 would be 150. And then 4 times 5 would be 20. Half each of those again, divide each of those by 10 to get 15 over 2. We need to have 7.5 painters are needed. Now, obviously, I can't get half a painter, so the number of painters, so least number of painters, least number needed, will equal 8 painters. Okay, the assumption that I've made in answering my part A is that every painter will paint at the same rate. Okay, so all painters paint at the same rate. Okay, so the next thing we're told is this is a blank page, so we skip through on to question 9. So question 9, I can see straight away, is a histograms question. I know it's a histogram. A, because it says it's a histogram, and B, because I was looking at the y-axis that says frequency density. Now, as soon as I see that, I'm always going to write down the formula. Frequency density is equal to frequency divided by class width, but I'm going to do it in a triangle. Okay? It's then asked me to calculate how many members of the running club are under 30 years of age. Now, this says this is the time taken to run 400 metres for each member of the running club, and these are for the members who are under 30. So these are my under 30 members. Frequency density. So if I want to work out the frequency, I'm going to do the frequency density times by the class width. So I'm going to do this class width being 50 to 4. This is a distance of 4, times by 4 would be 16, 12, and then a width of 8 times by a half would be 4 people in there as well. So it's going to be 4 add 16 add 12 add 8. Look for number bonds. 4 and 16 is 20. That's also 20. So we've got a total. Oh, hang on. I made a mistake here. This is a width of 8, and then half of 8 is indeed 4. 4 and 16. Why have I said 8 there? I've done 2 4s added to each other. 4 add 16 is 20. 12 add 4 is 16. So 20 add 16 would be 36 people. I'm then asked to calculate the median. This is easily the hardest bit of this question, okay? This is what people, when they're doing histograms, hate doing, okay? So, to work out an estimate for the median, I'm looking for half of 36. I'm looking for half of that, which would be the 18th person, okay? Now, I know the first 4 people were in that bar there. So I know all of this bar is taken up, and I would assume that's been split up into 1, 2, 3, 4. Okay. I then know that up to 4 and 16, up to 20, Mr. 20 person took 58 seconds. Okay. So the 20 person's there. I'm looking for Mr. 18. I'm trying to find out where they are. Okay. So what I'm going to do is draw a line where I split this bar into a number that I don't actually know what that is. I've just done it by eye. Because I'm after the 18th person, I know 20 is up to there. 4 add 14 would tell me where the 18th person is, and there would be 2 left on this side here. Now, I know that within this bar, the frequency is 14, and I know the frequency density is 4. To work out the class width of that bar, I need to do frequency divided by frequency density. So 14 being the frequency, and 4 being the frequency density. So class width equals 14 divided by 4. That is the same as 7 over 2, which is 3.5. So the width of this bar here would be 3.5. So 3.5 on from 54 would tell me that the median person would be 54 plus 3.5 would be the 57.5 would be my time in seconds for my estimate for my median. Okay? Very tricky question that, not easy at all. Okay then, the next question says, complete the table to draw the histogram and illustrate this on the graph paper shown below. So again, I'm going to draw that triangle. So that is my frequency density is equal to frequency divided by class width. And to work that out, I need to know all the class widths. So 50 to 54 is a class width of 4, class width of 4, class width of 2, class width of 2, class width of 8. So frequency density is frequency divided by class width. So 4 divided by 4 is 1. 10 divided by 4 is 2.5. 16 divided by 2 is 8. 18 divided by 2 is 9. And 12 divided by 8 is 1.5. Okay. Now I need to go and draw that. So I'm hoping I can get up to 9 in simple steps. So 2, 4, 6, 8, 10. Yep, that would work. 2, 4, 6, 8, and 10. I'm just going to sharpen my pencil very quickly. And I've got to go from 50 to 54 up to 1. So literally just there to there. Okay, I'm going to draw all the sort of the horizontal lines at the end of this. Then I'm going 54 to 58 is 2.5. Okay, so this would be 3, so it's going to be 2.5 little squares up. And then up to 8. Then up to 9, but it's halfway through. There. 9 again is the highest. There. And then 1.5 for the last bit going up to there. So 1.5 will be there, and then 2.5 little squares up. Okay, now I'll do all the horizontal lines. What's that, 2.5? Okay, so your histogram should look something like that by the time you've drawn it. It then says, C, on average, which of the two groups was faster at running the 400 meters? Give a reason for your answer. So if we compare the two histograms, we look for where the biggest peak bar is, the over 30s, is between 60 and 62, whereas the biggest peak for the under 30s, unsurprisingly, is quicker because they're younger. You'd assume they could run faster. So I'm going to say the under 30s. Under 30s because highest frequency density was at a quicker, highest frequency density bar, that should say, was at a quicker time. Okay? Okay, the next question, number 10. It says, the graph shows a 120-second section of Yeston's car journey to work this morning. At time 50 seconds, estimate the acceleration of Yeston's car in meters per second. Leave your answer as a fraction. So the key thing here is to find where 50 seconds is on your x-axis, which would be here. You come up, it's this point here we're interested in. You get a point there, and you then want to draw what I always describe as the bow tie. Now, a bow tie, when it's worn, would have the same area of material either side, so it should look something like that. You wouldn't want a lopsided bow tie that looks like this or this, okay? So when I'm getting my ruler there, I want the same amount of area each side. So that looks pretty good to me. But if I had it here, look, tiny slither of area there, big area here. So it's got to look roughly the same. That to me looks pretty reasonable. So drawing the tangent there will get me a mark. The next thing I need to do is to work out the gradients to find the acceleration, okay? So this is the gradient, and the formula we use to work out the gradient for the acceleration, or the one that I use anyway, is rise over run. Now to do that, I always in the graph. So I'm going to move the camera down a little bit more and focus again. Okay, there. Now, I like going one full box because I know that's 5, okay? So I'm going to look to see where it's landed nicely on a line there. And then I'm coming up here and looking to this point here. I'm now going to draw a triangle for that. Okay. By 5. And now I need to work out the run. So if you come down and check the axes, we know that one big square going across is worth 20. So each little square must be worth 2. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 there. 11, 12, 13, 14, 15. So I've got 15 lots of 2. So this has gone across 2 for me. So then, coming back up here so you can see a bit more clearly. The rise, which was 5, my rise was 5, divided by my run, which was 30, I've run along 30, would be 5 over 30. I could cancel that down, but it says just leave your answer as a fraction, it doesn't say in simplest form, so that'd be absolutely fine. Okay, the next question on the other side says, at another time, Yeston calculated its acceleration of the car to be 0.24 meters per second recurring. Write this as a recurring decimal as a fraction. Okay, so the way I do these is I leave a line and I say x equals what that fraction is, 0.24, but now I don't write the recurring dot. I just write it literally as a decimal. Okay, now from here, we then want to times that by 10 because it's only got one dot. If it had two dots, I'd times by 100. If it had three dots, I'd times by 1,000. So above it, I line up the equals and the decimal in perfect order, times by 10, and then move everything across. When I take away these two sides from each other, again, line up your equals, line up your decimal. 4 take away 4, these are all cancelling out until we get to 4 take away 2, which is 2, 2 take away nothing, which is 2, and then 10x take away x, which is 9x. X is equal to 2.2 over 9, but there's a problem. It's got to be as a fraction, not a decimal. So I need to make sure that I've times 22 over 90. Again, the next part of the question, part B, we're going to have to go back to the graph. It says, calculate an estimate for the distance travelled by Yestin's car in the first 80 seconds of his journey. You must consider the car speed at t0, 20, 40, 60, 80. So a pretty bog standard trapezium rule question here, okay? So at 0, fire up your line, already there. Then at 20, then at 40, then at 60, and again at 80. What I do now is I call those areas A, B, C, and D, because I'm only up to the first 80 seconds of the journey. And then I consider those as trapezium. So effectively, that would be a trapezium there. So although I'm over the area there, I'm under it there. So we're saying that they're going to cancel out to a degree. That's why it's an estimate. Same here. That would be a trapezium there. Again, the trapezium will be more. It's not really that much. But here, when I go there, I'm getting less area than I should do really. Okay, so we're saying they average out. Okay, and the more strips that I split it into, the more accurate my guess would be. Okay, so to work out area A, that is going to be a trapezium, which is a half of the parallel sides. So the parallel sides would be the lines I fired up, of 10 and 15. 15, I should say 10 first. 10 and 15, times by the height, times by the distance between the parallel lines, so times by 20. Okay, so the way that we're going to do this is we're not actually going to do it in the order that it says. A half times this times 20. Well, what's a half of 20? It's 10. Add these together and times by 10. So 15 add 10 would be 25, times by 10 would be 250 meters represented in that first trapezium. Now for B, trapezium again, a half of, we know what that one was, so I just finished on it, that's 15, and now it's going to go up to 25. So 15 add 25, so that and that becomes, the last one there becomes the first one there, times by 20. Add those two together, 40, half of 20 is 10, 40 times 10 is 400. It'll be 400 meters. For C, I can certainly do the first bit without even looking at it. It's going to be half of 25 plus something, and then times by 20. So for C, that gets up to 30. 25 plus 30 is 55, times that by 10 would be 550 meters. And then finally for D, now D is actually a rectangle, so it's just going to be 30 times 20. 30 times 20 is equal to 600 meters. I now want to add those two together, those four. Be smart about it, look for number bonds, there's 1,000. Add the 50 onto that, so 1,600, 1,800. Okay, doesn't need to be hugely difficult if you can spot certain patterns. It then says, hence, now that's usually quite an important word, calculate an estimate of the average speed for Yestin's entire 120-second journey. Now that's the difference here, okay? Here, above, we just worked out the first 80 seconds. They want me to work out the 120 seconds. So, coming back to my graph here, we're going to look at this. Now, I'm actually going to estimate it. It's an estimate after all. I'm going to say that that last bit's basically a rectangle as well. Okay? I'm over exaggerating by this tiny slither here, but look, I've also got a tiny slither out there, so I'm going to say they're going to cancel out. So that dimensions of E for me would be 80 to 120, which is 40, up to 30, okay? So I'm going to say E is equal to, was it 30 times by 40? So that's equal to 1,200 meters. So total distance would be equal to 3,000 meters. I then want to do speed is equal to distance divided by time. And I want to work out the speed. So the distance is 3,000 meters, the time is 120 seconds. So the speed is equal to 3,000 divided by 120, divide top and bottom by 10, then halve top and bottom to get 150 over 6, then divide both into, they both go into 3, don't they? So 50 over 2, and then 50 over 2 is 25 meters per second. Okay, then over the page, we're on to the last question, but split into two long bits here. Okay, so not a million miles off finishing, but take your time on this one. It's quite a nasty question. And go and find your formula sheet as well, because it's going to come into handy at some point. It says, in the diagram below, the wooden end piece for a curtain pole. The diagram below shows this. Okay, in the shape, a cone with measurements shown in the diagram, so 12 under diameter of 10. And then it says, a cylindrical hole has been drilled into the end piece. The hole has a radius of 3, so I'm going to go and draw these in, okay? Radius obviously going from the centre to there, that's 3. And then it has a depth of 4. So this dotted line here, that's 4 centimetres. Okay? It then says, show that the volume of wood remains is 64 pi. So they want me to do all of this without a calculator. Now, the way I'm going to start this off is by writing a formula in words, okay? So the volume of what's left would be the volume of the cone. So I'm going to say V of cone, take away the volume of the cylinder. Okay, that's going to help me set up this. Now, I've got to ignore the fact that it says 64 pi there. That stays as blank for now. And I go and prove that that's what my answer is. It's basically just saying, look, this is what you should get if you've got the right answer. It's telling you what the final answer should be. Okay, but you can't use it. The volume of a cone. The formula we use for the volume of a cone is a third pi r squared h, where r is the radius of the cone. We are given 10, which is the diameter of the cone. So I'm going to go and write in there the radius is 5 centimetres. So I know the volume of the cone would be a third pi r squared, so 5 squared, times by the height of the cone, so times by 12. Take away the volume of the cylinder. So that's pi r squared, which is the area of the circle, so pi times 3 squared, and then times by how long it is, so times by 4. Okay? Now, we're going to do things in a clever way here. Just like I did a moment ago with the trapezium rule question, I'm going to do things in a slightly different order. These are all times each other, so we can do them in any order we want. A third of 12 I know is 4, and then 25 is 5 squared pi. Okay, so 100 pi comes in there, and then 3 squared is 9. 9 times 4 is 36. So it's going to be 100 pi take away 36 pi, which is 64 pi centimetres cubed as required. That's what they told me there. But I've got to pretend that I haven't got it in the answer. I just need to show that this is what you get. Okay. We're then told for part B, it says the surface area of the end piece is to be painted except the area inside the hole. Calculate the area that is to be painted. Give your answer in terms of pi. So what they're after is what this length here is. Okay. This bit here. The end. Let's just read it again. I think it might be the curved surface area as well. So that bit's to be painted. It says the surface area of the end piece to be painted except for the area inside. Calculate the surface area that is to be painted. The surface area of the end piece is to be painted. Okay. Surface area of the end piece is to be painted except for the area inside. Calculate the surface area that's to be painted. Well, they're also going to paint all of this bit here as well and use a different colour. Okay, so all of this is to be painted. So what I need to do is to work out, now obviously it would come around here, but it'll go over the orange bit. I need to go and work out what that would be. So again, I'm going to do that in terms of a worded formula first. So I'm going to say surface area is equal to the curved surface, or the curved cone bit. And then we want to add on the orange bit, which would be the area of the big circle, take away the area of the little circle. So it's to say big circle area, take away the little circle area. Okay, now from there, I need to go and use the formula from here, which tells you that the curved surface area of the cone is pi RL. So that's going to be pi RL. Now, if we look to see what L is, here, that's this side here, the diagonal. Now, here, the height is straight up, the radius is the bit that's across. So if I actually go and draw on the one on the formula here, we know that height comes straight up, and if I have my radius going straight across, can you see there that I'm making a right angle triangle? So if that's h, that's r. This is just Pythag, so r squared plus h squared would equal l squared. So r squared plus h squared would equal l squared. So if I come to my one here, I know that 12 is this distance straight up from the centre. That's 12. I need to go and work out what this bit here is, okay? But bear in mind that that's all of this distance here of the cone. So it's going to be, so to work out L, I want to do 5 squared, which is that distance there, plus 12 squared would equal L squared. 5 squared is 25, plus 144 is equal to L squared. That's 169 is equal to L squared. Square root 169 is equal to L. L is equal to 13. Okay. Then we're going to add on the area of the big circle. So it's going to be pi times by radius squared. Take away pi times by radius squared there. Okay. So now substituting into that, the area of the curved cone, remember the radius was 5, is going to be pi times by 5 times by 13 plus 25 pi, take away 9 pi. 5 times by 13 is 65, so 65 pi, and I want to add on 16 pi, because 25 pi take away 9 pi is 16. And then finally, 65 pi plus 16 pi would be 81 pi. Okay, that was the last question. I hope you found that useful. If you did, please hit the subscribe button and you'll get first access to any more videos as and when I upload them.